This is, I believe, UV, visible spectra, and then forward-looking infrared.
Yeah.
And one of the things that I love about your work, and this has been since the very beginning, when I saw you at the SCU conference last year, you have been working on multiple spectra independently, right? And so
yes.
the thing that excites me about that is there are so many videos out there, like the Skywatcher team brought several in, where you have optical spectra, but then you've got JPEG compression, you've got weather patterns and clouds, you have all sorts of stuff, and it's difficult to tell, right? Is this, what is this? What is it that we're seeing? And so having more of those spectra helps you validate, hey, this is doing something strange in this spectra, it's doing something strange in the other. And then you've also looked at passive radar, right?
Of course, yeah. So that's a great segue into where we really need to go, is getting into multimodal data. That's going to be the key in making sense of what we're seeing and what we're experiencing with regards to UAP, so that we can bolster our conclusions about what's going on through the data. The data is everything, right? We have to take this from a biased point of view, which is not inherently wrong. It's just we're working with a limited framework of understanding. Once we go to the data and different forms of data from different sensors, we can be more objective in our understanding of what's going on to make really informed conclusions. So yeah, with regards to passive radar, we do have a software-defined radio, commonly used RTLCRs, that can be used as a passive radar. So passive radar, all it is you're using an active transmitting source in the area that you're in. So that can be an FM radio tower or digital television tower. You're locking into that frequency, tuning the SDR programmatically or digitally to that frequency. And then what you're doing, you want your antennas to also be, with respect to the wavelength of that transmission, correctly tuned. And then you have the antenna oriented to the direction of that transmitting source, and anything that goes in between that transmitter and you as a receiver, your antenna, you can actually pick up the perturbations or the disturbances of that signal in real time. So you can map that out over time, and you can create like a passive radar map over that to track position, velocity, and acceleration of potential UAP.